Hello! In lesson 4-2, we're going to talk about the angles of a triangle. Let's begin. Take a look at our triangle. We're going to prove that angle A plus angle B plus angle C equals 180 degrees. So to do that, let's bring in a parallel line. We'll call it line L. What we have to do is prove, well, we'll call these angle 1 and angle 2. Given that line L is parallel to line AB, prove that A plus B plus C equals 180 degrees. Let's do the proof. We'll do a 2-column, so statements and reasons. Of course, remember you always begin a proof with the given information, and our given is that line L is parallel to line AB. Notice that line L is 180 degrees, so therefore the measure of 1 plus the measure of angle ACB plus the measure of angle 2 equals 180 degrees. That's the angle addition postulate also. These three angles form the straight angle, which is a straight line, which is 180. But notice, if these lines are parallel, what do you notice about angle 1 and angle A? What special pair of angles do they form that we learned about in chapter 3? That's right, they're alternate interior angles. And if the two lines are parallel, remember alternate interior angles are equal. Same thing with angle 2 and angle B. They're alternate interior angles, and they're equal. Well, if the measure of angle 1 equals the measure of angle A, remember, anytime we see 1, we can replace it with, they're right, A. And anytime we see 2, we can replace it with B. So by the substitution property of equality, we can replace 1 with A and 2 with B, and we have proven what we're asked to prove. The measure of A plus the measure of C plus the measure of B equals 180. This is such a powerful thing that we give it a name. That is the triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. Very, very important. We use this a lot. Any triangle, the sum of the measures of the three angles is always 180 degrees. Let's move forward. Let's use it in example 1. Find the measure of each angle indicated. Here's our triangle. We know 2 of the 3 angles. Find the third. The third angle, the sum is 180, so it's 180 minus the sum of the 2 that we know. 90 plus 70 is 160, and thus the third angle is 20 degrees. Take a look at a second example of this. We know 2 of the 3, find the missing one. So again, it's 180 minus the sum of the 2 that we were given. 79 plus 52, that comes up to 131. 180 minus 31, this third angle is 49 degrees. We can also do a little algebra. Solve for x. Triangle angle sum theorem says that the sum of the angles of any triangle is 180. So x plus 66 plus 40 plus 80 has to equal that 180. Combining our like terms, we get 186. We'll subtract the 186 to both sides, and we find out that x equals -6. Now, don't panic and think, well, Mr. Giesting, a triangle can't have a negative angle. You're right. But notice that this expression is x plus 66. So x, the variable x, can have a negative value because when we add -6 to 66, we get a positive angle measure. So when you're solving for a variable, you can get a negative. When you're just finding the third angle of a triangle, you can't get negatives. One more example of this. Let me move myself out of the way here. Again, triangle angle sum theorem. The sum of the angles of any triangle is 180. So x plus 69 plus 40 plus 80 equals 180. Combining the like terms, again, we get x plus 189 equals 180. So again, we're going to get a negative x when we subtract that 189 to both sides, and thus x equals -9. Again, because we're solving for a variable, negatives are okay. Because once we add -9 and plug it into this, we're going to get a positive angle measure. That's the first way we use the triangle angle sum theorem. Let's move forward. Find the measure of angle A. So again, we're going to have to set up an equation. That being that we can add the three angles of a triangle together and it always equals 180. Triangle angle sum theorem. 12x plus 2 plus 7x plus 4 plus 79. So we're going to gather our like terms. That's the 12x and the 7x and the 2 and the 4 and the 79. We get 19x plus 85 equals 180. Now we're just doing a simple algebra equation that you've been doing for a couple of years now. So we'll subtract the 85 on both sides. 19x equals 95. And thus x equals 5. Now, they don't want to know what x is. We need x, but they ask what's the measure of angle A. So to finish this up, angle A is 7x plus 4, so putting 5 in for x. 7 times 5, and actually I have a math mistake on here. This should actually be different than this. It should be 35 plus 4. The answer should be 39. So make sure and correct that when you write this down. Taking a look at this example. Again, we use the triangle angle sum theorem that 11x plus 24x plus 2 plus 73 equals 180. Again, we'll combine our like terms. 35x plus 75 equals 180. Subtract the 75 on both sides. 35x equals 105. Divide by 35, and we find out that x equals 3. And again, we'll plug that in because they don't want x, they want angle A, 11 times 3, or 33. Final thought of today's lesson. A triangle can have exterior angles that are formed by one side of the triangle and the extension of an adjacent side. Let me show you what I mean. Here's a triangle. The extension of the adjacent side. So we're going to form an exterior angle, exterior of course meaning outside. So we're going to form an angle outside the triangle with this side and the extension of an adjacent side. 3 is an exterior angle. Now, each exterior angle of a triangle has two remote interior angles that are not adjacent to the exterior angle. So if 3 is the exterior, the two non-adjacent angles, 1 and 2. They're known as remote interior angles. Depending upon the exterior angle that you're talking about, that's where your remote interiors come from. If I extended, say, down here and extended this side, then I have these two as remote interior angles. Well, something important coming up. Exterior angle, the remote interior angles. The two interior angles that are not adjacent to the exterior angle that you're talking about. Well, what I need you to notice is this. If I took this red angle, the exterior, and this angle right here where I'm pointing to with my arrow, that would have to add up to what? You're right, 180, because they're a linear pair. But these two, remember the triangle angle sum theorem says that the three angles of a triangle also equal 180. So this plus this is 180. Angle R plus angle S plus angle T is 180, and we discover this. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Back to my diagram here, the measure of angle 3 equals the measure of angle 1 plus the measure of angle 2. Illustrated this way. Again, the measure of angle 3 equals the measure of angle 1 plus the measure of angle 2. An exterior angle formed by extending a side is equal to the sum of the two remote interiors, the non-adjacents to that exterior. Let's do a couple of examples. Find the measure of each angle indicated. I want to know the measure of this angle right here. Well, 130 is an exterior. It's equal to the sum of the two remote interiors. So the unknown angle plus 55 has to equal that exterior angle of 130. We can subtract 55 on both sides, and we find out that this interior angle right here is 75. Here, I want to know what the exterior is. Well, it's equal to the sum of the two remote interiors. So the question mark equals 60 plus 60. This angle has to be 120 degrees. By the way, what kind of triangle would RQS be from lesson 4.1? You're right, it's equiangular. We can also set up equations. If we solve for x, notice that 6x plus 4 is the exterior. The 2x plus 12 goes up here to angle F. So we can write the equation, the exterior angle, 6x plus 4, equals the sum of the two remote interiors, 2x plus 12 plus 40. So we'll combine the like terms, 12 and 40 make 52. We'll take away 2x, moving all the x's to the left and moving all the constants to the right. We get 4x equals 48. Divide by 4, and we'll find out that x equals 12. Last example, again, the exterior angle is equal to the sum of the two remote interiors, 2x plus 10 plus 103. Again, we can combine our like terms, solve the equation, take all the x's to the left, all the constants to the right. 14x equals 112, and thus we find out that x equals 8. And that is the end of lesson 4.2. Oh, almost the end of lesson 4.2. Psych! Made you think. A corollary is a theorem without proof that follows as a direct result of another theorem. So a couple corollaries. These are kind of things that when you think about it, they're just going to make sense. Triangle angle sum corollaries. The acute angles of a right triangle are complementary. Remember we learned in lesson 4.1 that a right triangle has one 90-degree angle. Well, if one of the angles is 90, 180 minus 90 means the other two have to add up to 90. That's what complementary is. 4.2, there can be at most one right or obtuse angle in a triangle. The triangle angle sum theorem we learned in this lesson says that the sum of the angles of any triangle is 180. Well, if it has two right angles in it, that's already 180 before you add the third angle. Two obtuse angles, which are more than 90, if you add those together, you get something greater than 180. So it can't be. They can only have one right or one obtuse angle in a triangle. And thus, that is the end of lesson 4.2.